All right, so for today's lesson, we're going to talk about end behavior of rational functions. In the first half of this unit, we talked about the end behavior of just a general polynomial. Today, we're talking about end behavior of a rational function. So it'll have the same meaning. Remember, end behavior is what happens at the ends, what happens as x gets really, really large in the positive direction, or what happens is x gets really, really small or large, I guess you could look at it that way, in the negative direction. And it involves polynomial division, which we've talked about before. All right, so to find the end behavior of a rational function, we divide out the polynomials, and the end behavior approaches the answer, and this is the key, without the remainder. So really the hard part is just to make sure you do the division correctly. So for our lesson examples, let's take a look at the first one, 2x cubed plus 3x squared plus 7x minus 5 over x minus 2. That's a rational function. And we're going to find the end behavior of that rational function. All right, so I've already set it up over here. I've already gone ahead and set that up. So let's do the division. So we know that x times 2x squared is 2x cubed. If we finish out the column, this will be a negative 4x squared. Negative 2 times 2x squared is negative 4x squared. For this diagonal, we need a positive 3x squared, but I have a negative 4x squared, which means that this needs to be a positive 7x squared. 7x squared and negative 4x squared combine to positive 3x squared. Next column, x times 7x is going to give me 7x squared. All right, that's going to make this a negative 14x. Negative 2 times 7x is positive 14x, For the diagonal, we need to go from negative 14x to positive 7x. All right, so that means this needs to be a positive 21x. 21x and negative 14x combined to positive 7x. And that's going to make this x times 21 is 21x. And that's going to make this last one negative 2 times 21, negative 42. Obviously, that means there's a remainder here. So what is my remainder? Well, I need my constant term I got was negative 42. Constant term I need is negative 5. So to go from negative 42 to negative 5, that means I have to go up by 37. So my remainder is positive 37. If I take negative 42 and I go up by 37, I'm at negative 5. So my answer when I divide is 2x squared plus 7x plus 21 plus 37 over x minus 2. So that is the answer. That is what we get when we divide. So that is the first step to finding the end behavior. The answer for end behavior, the end behavior approaches the answer without the remainder. So in this case, the end behavior is going to simply just be the answer with the remainder taken out. So in this case, that is going to be 2x squared plus 7x plus 21. That is the end behavior of this rational function right here. Now, what does that look like visually? Okay, so if I look at a graph of this rational function, and I have one here, okay, here is a graph of that rational function. It looks a little weird, okay? So here's the graph of the rational function. That's the red graph. Now look what happens when I put in this 2x squared plus 7x plus 21. So when I put in the answer without the remainder, I have this. Obviously, those graphs are different. But if I zoom out, notice the green graph and the red graph are clearly different. But the more and more I zoom out, hopefully you notice that those graphs will start to look closer and closer together. They'll look more similar the more I zoom out. Okay? The more I zoom out, I can't tell the difference between the red graph and the green graph because I've zoomed out so much. They look so similar. That is what end behavior is. So that is what it looks like visually when we say end behavior. Let's go ahead and do quickly number 2 in our examples. All right, so we have 3x squared plus 7x minus 5 over x plus 2, and we're going to find the end behavior of that rational function. All right, so let's divide this out here. So x times 3x is 3x squared. That's going to make this a 6x. Okay, for my diagonal here, 6x plus, looks like we need to make this a 1x. 6x and 1x gives us 7x. All right, for our next column, okay, x times 1 is x, and that's going to make this a 2. All right, so obviously we have a remainder here. Okay, so my constant term I got was 2. The constant term I need is -5. So to go from 2 to -5, I need to go down by 7. So my remainder is -7, which makes my answer 3x plus 1 minus 7 over x plus 2. Okay. And just like in the last one, our end behavior is going to be the answer without the remainder. So my end behavior for number 2 is simply going to be 3x plus 1. Okay, that is my end behavior for number 2. What is that going to look like visually? Well, let's go to the graph here. Again, the red graph here is the graph of the rational function 3x squared plus 7x minus 5 over x plus 2. And then let me put in the graph of the answer without the remainder, 3x plus 1. Obviously, those graphs are clearly different. The red and the blue graph are different. But if I start zooming out, okay, if I zoom out enough, okay, the red graph and the blue graph almost become indistinguishable. They almost look exactly the same. And that, by definition, is what end behavior is. So your cool down today will be one more example just like this, just like the 2 that we've done, just a different rational function. So make sure you've written these examples down, you've written the notes down, and that you ask me questions if you have any.